Well, good morning, everybody. Happy Monday. Hope everybody had a good weekend. Ready to have at it and start working on a new warm up. Okay. This is the last week before Thanksgiving break. All right. So, what do we got going here? We have a week on, a week off. Then you come back for 3 weeks on, and then you have 2 weeks off. So, we've got a lot of time to rest over the next couple months. A lot of time off. So while you're on, put the pedal to the metal, huh? Let's work hard. Okay, let's work hard because we only really have 4 weeks left in 2020 of work and a lot of time off. Okay, so let's work hard. I challenge you to press pause, copy down this warm up, and get it all done, right? Get as much done as you can. Come back in spots when you need help, and then come back and check your answers. All right? We'll see you in a bit. Okay, everybody, let's see what you got. First off, what word goes here and here? Well, what is the 42 in the diamond, right? The 42 on top, that's the answer. When you multiply two numbers, that's called the product, right? And what's the 13? Well, that's when you add two numbers or more. That's called the sum. Same thing with the product. It could be 2, 3, 4, 5. When you're multiplying a bunch of numbers, the answer is a product. When you're adding a bunch of numbers, the answer is a sum. Okay, what two numbers work there? Well, if you have not got that answer in your brain, you haven't been doing the warm-ups enough, right? Because that one shows up a lot, 42 and 13. How about 51 and 20? 51 is there because I want you to get it in your brain that it is not a prime number, because that's one they trick you with a lot when they ask questions about prime numbers, right? And how do you see if a number is prime? Well, first you check prime numbers, right? And 2 is the first one you check. It's even. All the multiples of 2 are even. 1 is odd, so 2 won't. All right? By the way, you ever have trouble keeping track of odd and even numbers? And you know, one of them is the 1, 3, 5, 7, 9, 11, and so on. The other one is a 2, 4, 6, 8, 10. Right? Whoops, didn't go in order there. Well, here's what you do. Write the word odd, write the word even, and then count the letters. How many letters in odd? 3. How many letters in even? 4. That will help you remember which ones are odd and even. Okay? All right. Back to work. 51 and 20. The next number you check is 3, and there's a trick with 3s. The trick is you add the digits. 5 plus 1 is 6. Does 3 go into 6? Yes, then 3 goes into that number. 52 is 5 plus 2 is 7. 3 doesn't go into 7, so 3 doesn't go into 52, right? But 2 does because it's even. So that's a good trick with 3s. So 3 goes into it how many times? Well, it turns out it's 17 times, and 3 plus 17 is 20. All right, 2 and 4 tenths, 12 and 2 tenths. 12 and 2 tenths. How does that work, right? 2 times 12 is 24. Remember, you pretend like there's no decimal, and then I had to go over one spot to pretend that was a 2 instead of 2 tenths, so I have to go back one spot in my answer. When I add, remember, you stack them and line up the decimal. Where is the decimal in 12? Remember, it goes to the right if there's not one there. So 0.2, and then when I add those, I got a 2 here, a 2 there, and a 1 there. 12.2. All right. How about 24 hundredths and 1 whole? Ooh. Well, it just so happens that 6 plus 4 is 10, and 6 tenths plus 4 tenths is 10 tenths, and 10 tenths as a fraction looks like that. It's 1 whole. But you go and multiply 4 times 6 is 24, but I had to pretend it was there was no decimal by moving it over there once and there once. That's twice, so I have to go back 2 spots. That's my answer there. When I add, remember, you stack them and line up the decimals. I saw some kids did their homework, and they had some problems where the decimals were written horizontally, and they didn't stack them before they got their answer. So that made me think they're not listening to me. I took a point off. You can't get 10 out of 10 or 9 out of 9 if you're not following my directions. 1.0 is the same as 1. All right, prime factorization. 5 times 5, and 5 is prime, and 5 is prime, so 5 times 5 is the prime factorization. You can also write that 5 to the second power, or 5 squared. 26, it's even. 2 times what? 13. And guess what? Both of those are prime. So 2 times 13 is the prime factorization of 26. 27, 9 times 3, and 9 is 3 times 3. So I end up with 3 3s here. 3 times 3 times 3. Can you write that with exponents? Yes, you can. And 7 times 4, and the 4 is a 2 and a 2. Put them in order. It's not 7 times 2 times 2. It's 2 times 2 times 7, or 2 squared times 7. Now, I wanted to talk about sometimes asked for the prime factorization, and you have to make those factor trees, circle the numbers, and get the numbers on the bottom, right? Sometimes they just say, what are all the factors? When they want all the factors, don't be making a tree, okay? You want to find out what numbers go into it and equal 25, and 2 doesn't, 3 doesn't, 4 doesn't, 5 times 5, there's no numbers between that. So all of the factors of 25 are 1, 5, and 25. That's how you get all the factors, okay? There was some confusion when we had a homework a couple weeks ago on that, or last week. And this is 2 times 13 and 1 times 26. And really, I like to start with a 1, so I'm going to do this again. Now, 3, 4, 5, 6, right? None of those numbers go into that. So that's it. It's just 1, 2, 13, and 26. Okay? 27, I have 1 times 27. And 2 won't fit, but I have 3 times 9. And does 4, 5, 6, 7, or 8 go into it? No. So I'm done. 1, 3, 9, and 27 are all of the factors of 27. That's how you do that. So don't get confused. Sometimes ask for prime factorization, and that's when you're making a factor tree, finding the numbers that you circle, and putting them in a multiplication problem. All the factors is they want to find out any number that fits into it without anything left over, okay? All right. How do you change a fraction to a decimal? Okay, and this is new for you. I've never taught you guys this. So you want to write in big letters in your folder somewhere, divide the bottom into the top. What does that mean? 1/4. I'm going to divide 4 into 1. And you say, but wait, teacher, 4 won't fit into 1. Well, that's true. The fraction, the bottom will never fit into the top unless the top's bigger than the bottom. If the top's bigger than the bottom, it's an improper fraction. Yeah, you can still do it, but so in a normal fraction, it's never going to fit. So what do? Well, I make 1 1.0, and I bring the decimal up, right? And now I'm pretending there's no decimal there. I'm just saying 4 into 10. Okay, so you're always going to add a decimal, bring it up, and add a 0. Okay, remember you can do that. Any whole number, 5 is the same as 5.0. It's the same as 5.00. I can keep adding zeros. Okay, so all you have to do is divide the bottom and the top, but no, if it's a normal fraction, you're going to add a decimal and a 0. Okay, so now I divide. 4 goes into 10 twice, and that's 8, and that's 2, and I got a remainder, so I'm going to add another 0. 4 goes into 20 5 times, and that's a perfect fit. So 1/4 is the same as 0.25, which makes sense because that's a quarter of a dollar, right? A quarter looks like that, 0.25. Okay? So divide the bottom into the top. 1/2, divide the bottom into the top. 2 into 1, but it won't fit. Add a decimal, bring it up, and add a 0. 2 goes into 10, perfect fit. 5/10 is the same as 1/2. And I said 5/10. If you closed your eyes and I said 5/10, you wouldn't know if I said that or that because you say it the same. Okay, and you know that's 1/2 because we know how to do that magic 1, divide the top by 5, the bottom by 5. It goes back to a half. Okay, so to go from a fraction to a decimal, you're going to divide the bottom into the top. Now, sometimes there's problems with that. 8 into 3, it won't fit, but wait, it won't fit. Add a decimal, bring it up, and add a 0. 8 into 30, 3 times. 3 times 8 is 24. Add another 0. 8 into 60, 7 times. That's 56. Yeah, I got a remainder. Add another 0. 8 goes into 40. Nice even 5 times. So 375 thousandths, or 0.375 is 3/8. 3/4, divide the bottom into the top. But Mr. Daniel, it won't fit. Oh man, that's getting old. Add a decimal, bring it up, add a 0. 4 into 30. Right, how many times? Is that 6? Now it goes 7, huh? Sorry. 7 times 4 is 28. I'm doing that 24. All right, got a remainder. What do? Add a 0. 4 into 20, 5 times. And that makes sense too, because 3/4 of a dollar is 75 cents. Write that a little neater for you. 75 hundredths equals 3/4. 5/8. I'm going to do that in the back real quick, get a little room. 8 into 5, but it doesn't fit. Add a decimal, bring it up, add a 0. 8 into 50. 6. 6 times 8. Subtract. Add another 0. Now, are there some times when you're not going to add a 0? Yeah, I'm going to show you that. Whoops. I put the 0. I'm supposed to put the 0 there. I am just talking too fast here. All right, it goes 5 times into 40. Another messy one. Let's rewrite it. 5/8 equals 0.625. Trying to hurry because I don't want this to be too long, because I know some of you look at the time of the video and say, oh, that's too long, I ain't going to do it. All right. 10 goes into 70, 7 times. So 7/10 is the same as 7/10. If you were closing your eyes, you're saying, how come he's repeating himself? All right. What is in the perfect heading? I have so many kids missing points on homework because they don't do the easiest 3 points. Put your first and last name. Put your teacher's name and your period. Put the date. And if you're doing work out of the book, put the problem numbers. 7 through 24, whatever. On lesson 3.1.2, whatever it is. Okay? All right. Got to do that. All right. OOO means order of operations. What are you doing first? Parentheses always takes cuts. All right. Now, inside that, now I have exponents, subtracting, and multiplying. Exponents take cuts in front of everything else. 16 to the second power is not 36. It's 256. 2 to the third power is not 6. 2 times 2 times 2, it's 8. So now I have 256 minus 7 times 8. Don't subtract before you multiply. Ladies first. Adding and subtracting come last. 7 times 8. And now you're glad you didn't do that, huh? You would have had to multiply 8 times 249. So much easier to say, what's the difference between 256 and 56? Nice, even 200. And 5 to the second power is not 10. It's 5 times 5. And how many quarters in $2? It's a snowman. All right? All right. 14 to the second power is not 28. It's 196. 2 to the fifth is 32. 2 to the third is 8. What is 32 divided by 8? 4. What is the sum of 196 and 4? 200. That parentheses becomes 200. 6 squared is 36. 8 squared is 64. The sum of 6 squared and 8 squared is 100. What's the difference between 200 and 100? Boom. Boom. I will see you tomorrow. Have fun doing your homework today. And hey, we got some cool science coming your way in the Zoom. All right. See you soon.